Hello, in this sequence of video notes on the various applications of model forecast and GRIB format, I've come to the point of wanting to use the program LuckGrib that's available for the Macintosh computer or for iPads and iTablets. And I want to look at probabilistic winds, and this is the one program I know of that will do that. And so we'll start out, and also just quickly demo how this gets its data. It's the same as the other apps we've done. Let's just say look at this region, and then you go up and I want to say I want a high-speed internet. I could use satellite phones and so forth, but for now I just want that. And I'm going to go the standard GFS, and the parameters I just want wind and pressure. And that's all I need for right now is wind and pressure on the surface. This will take other data, and we only need, let's go out 6 days, and we'll take it every 6 hours for 6 days. We'll do that. And this is GFS. Okay, download. Okay, so there's then the data, and then this is let's see. Okay, so this is a forecast that's starting at 18 Zulu, and then we can see that and then we can just move this cursor and watch how, the isobars aren't showing. Let me turn on the isobars, the pressure. Okay, so we have the wind and pressure on the surface, and then we can go through and see how the system varies like that as time goes by. There's a big low coming up, and it looks like, let's just see what that looks like. See, this looks like a big front down here, these kinks in the isobars and so forth. But that we're not getting into the analysis of that right now. It turns out this is, as I looked a little bit earlier this afternoon, I think there's some very complex things going on here. But that's not the issue right now. Right now we want to talk about, let's just say I just picked a random point here. We could pick other points. And then this program, like the others, this program has, this is now, I'm going to put that point just right here, say, right at that point, and let's say here, okay, I'll make it like, 12Z, is that going to be right at 12Z? Yeah, 12Z on the 6th. And then, and we see, here's the pressure like that, and then here's a picture of how the wind varies at that point. Now look, it turns out to be, now I don't know if we can see it looking at that, just looking at the GRIB file, this model output. It's not that easy to tell that's exactly when the front went by. We could probably deduce that, but when we're looking at this picture, we know that's when the front went by. You see, the wind dropped here. Well, I don't know, wind doesn't normally drop when a front goes by, but it does definitely do this great huge veer, and then the wind built. So we're seeing what's going on. But here's the main thing. This is a deterministic model. At this point, this is what the GFS model said the wind is going to be. At 36 hours out, it's going to be 20 knots. At 48 hours out, it's going to be about 2 knots. That's its statement. All right, and so that's that. Now let's look at some other options. Let's go back here to our region, and then take the same region, and then go up here, and this time we're going to take a model, let's go to an ensemble model, US ensemble model, parameters. We're going to take pressure and wind, and then let me just now I'm going to take the standard deviation for the wind, and I think that's everything. Control member, no, we don't need any of that. Okay, so this is ensemble, means they ran 21 different model calculations, each time varying the inputs slightly, and then they get 21 different maps out. And then this is going to be a average. This is going to be the mean value of the wind and the mean value of the pressure, plus we get the standard deviations on the wind. That's what we're after. And again, we'll go 6 days and every 6 hours and download. Okay, so that's that. Now what I've turned on here is in the display. Let me just double check what I have in this display. Oh no, in the display, I've got the mean wind and the pressure, and then the color bar is the standard deviation. So that's what I want. And the standard deviation is how much the wind is uncertain. And now let's just look at this. Let's start here. And you see, if you look at this, and the data are up here in this corner. If you look at this wind here, look at this. That says the wind is 16 knots. 16 knots, west-northwest, and the standard deviation 1.4 knots. Now that's basically as good as it gets. In other words, there's no variation in that. In other words, they ran 20 different models, and the standard deviation in all of them is 1.4 knots. That's as good as it gets. So that's, in other words, they all agree that's got to be considered a good forecast for this area at this time. Now let's just keep going and go on. Now we see some uncertainties coming in. Look at this area now, for example, here. Again, over here, you've got 18 knots plus or minus 2.5, something like that. But now in this area, the wind is forecasted to be 14 knots. You see, this is a nominal. See, it's nominal 15. It actually, this is reading 16.6, but plus or minus 9 knots. Over here, you got 13 knots plus or minus 11 knots. In other words, let's go back and look at our meteogram here. Do I get it at the right point? That's the same point as before. So now what we see in this region here, you see here, before then, the wind's all very good. That's plus or minus a knot or so. That's perfectly good forecasting. But you get in that area, and that's a big area. Look at that, 36. That's a large number of hours here, where this, well, in fact, all the rest of the time, that whole zone is not any good anymore. Here the wind is forecasted to be 5 knots, plus or minus about, this is standard deviation of 15. It's, in other words, a totally unknown, the wind speed. The average of all the models, was 5, but they were spread out all over the place. Same way down here, you have a wind speed of like 25 knots, plus or minus, and this goes up to 40 and down to 7. In other words, the whole wind in this area throughout this area here, throughout this forecast, is just simply not known. Wow, there comes a totally unknown air. This means extremely high uncertainty in this vicinity here. Okay, so that's one way to look at that, and you would never know that from looking at just the GFS wind. Let's look at one other way to look at this, and I could go here. And I do the same thing. I get this area we're looking at. I'm going to do a new forecast, new request, and this time regional. Unfortunately, this is called regional, but it's not regional. It's I want to go down here. National Blend of Models, Oceanic. Did that shut that off? Yeah. National Blend of Models, Oceanic. And we have literature that discusses this. And in fact, okay, I'll show you that in a minute. So this is that we want to get the mean wind and the mean pressure, but then probabilistic winds. Let's get all these probabilities. We don't need significant height. Yeah, see, they don't have the CONUS. The National Blend of Models, CONUS, has standard deviation, but the Oceanic actually gives us probabilistic winds. So let's download that for 6 days, every 6 hours, and look at that real quick. It's just another way to take advantage of probabilistic wind forecasting. And okay, so here is this data. Now we're looking here at this is the mean value of those forecasts, and we would have to compare that. We would have to compare that to the GFS to see how they agree on the basic mean value. In other words, they say that's the wind, that's a 50% wind right there, and how that compares to the GFS. And I have a strong feeling that when you get beyond about 4 days, three or 4 days here, I think this National Blend of Models Oceanic is probably the best model. But below that, we got to look at other things. But now let's just bring this up here now. And to that same point, same point, and look at the different data. You see here is 10. the idea is when these are spread out like that, look, it's not quite so bad here as it was in the standard deviations. It's, in other words, in that area we were looking before, here it says the wind is the 50% of the wind. In the middle, 50% of the wind is about 10 knots. And then with this says there's only 10% chance of the wind being higher than about 15. So that's not so terribly uncertain as it looked like with the standard deviations alone. But so this is a little stronger way to look at it. But when you get over here, you see you have a wind speed of 27 knots, but you still have, this is 25% chance that it's going to be, this is 27. There's a 25% chance that it'll be below 22, and then down here you're reading 10% chance less than 20. So you see you have a picture here of the reliability of the wind forecast if you're making a decision. Now this comes into play, a little bit more into play when we're doing actually numerical routing, which we do. I'm working up to that here in the presentation of applications. But when you're doing having the program decide which way you should go best, which is your best route on your sailboat, then and if it's a risky route, you want to be sure that you're gaining, you gain enough by doing it. But, and I'll put this reference in here, but I have an article online about the use of this data in evaluating forecasts. And it defines the standard deviations like this. Here is defined. And there's another example given here. And then there's an example of the national blend of models, and here's a definition of these probability winds. And this link is in the article, which I'll link there. So I'll let it go at that. There's a lot to be studied to understand why these are, we can learn a lot. We can get so many parameters out of this data that we can understand why it might not be as good a forecast as other parts. It's why some parts are good and some parts are bad. We have enough data. But that's not the subject right now. Right now it's just what are the tools, looking at these different models to show you the probabilistic forecasts and how they can be presented.